In this video, I'm going to be doing an example of using the comparison tests, that is the direct comparison test and the limit comparison test, to determine if a series converges or diverges. So let's start with this series. Determine if the series converges or diverges. The sum from n equals 1 to infinity of n cubed plus 5 over n to the 7th minus 2. So let's start off by identifying what a sub n is. A sub n is going to be equal to n cubed plus 5 over n to the 7 minus 2. Let's then determine what b sub n is. Well, we compare this to, when we select our b sub n, we want to think about what is happening at infinity. Well, as n gets infinitely large, the plus 5 and the minus 2 really are insignificant. So we're looking at n cubed divided by n to the 7th. Well, n cubed divided by the n to the 7th is really 1 over n to the 4th. So we're going to compare this to 1 over n to the 4th. That is our comparison series. Now, first of all, we want to use the direct comparison test. For homework problems, I want you to do all of the problems both ways, showing all the wonderful work. Yay. So, b sub n is a converging, b sub n is a converging p-series. And since b sub n is a converging p-series, we want to show that b sub n is greater than a sub n for all n. And the reason for that is, to go back to this little picture here, if b sub n is converging, and it's kind of coming down like this and it's converging, and that's b sub n, and we've got a sub n, well, a sub n is less than it. If a sub n is always less than b sub n, it's always going to be underneath it somewhere. And so it's going to have to be squeezed in between b sub n and the axis, kind of like the squeeze theorem in essence. We're squeezing a sub n to convergence. So if b sub n converges, a sub n has to converge. So what we have to do is show that b sub n is greater than a sub n for all values of n. So to do that, let's take our b sub n, which is 1 over n to the 4th, and say that it has to be greater than n cubed plus 5 over n to the 7th minus 2. Or in other words, cross-multiplying, n to the 7th minus 2 times 1 has to be greater than n to the 4th times n cubed plus 5. Well, what that means is that n to the 7th minus 2 has to be greater than n to the 7th plus 5n to the 4th. Well, again, let's think about what's happening at infinity. At infinity, this minus 2 becomes insignificant. So what we have essentially is n to the 7th is greater than n to the 7th plus 5n to the 4th. That doesn't make sense because there's more terms over here. This is going to be, they're both going towards infinity, but this is always going to be larger than that. So this is false. What that means is, because this is false, a false assumption, b sub n is not less than a sub n for all values of n. So therefore, we cannot use the direct comparison test. So now let's go to the limit comparison test. So B, the limit comparison test, says that we are going to take the limit as n approaches infinity of a sub n divided by b sub n. So that's going to be the limit as n approaches infinity of n cubed plus 5 over n to the 7th minus 2. Instead of dividing by b sub n, I'm going to multiply by the reciprocal, which would be n to the 4th over 1. And so that becomes the limit as n approaches infinity of n to the 7th minus 5n to the 4th over n to the 7th minus 2. Well, we're going to do that thing. We could use L'Hopital's rule for both of these, but what I'm going to do is just do that little algebraic trick where we divide everything by the highest power of n. So this becomes the limit as n approaches infinity of n to the 7th over n to the 7th minus 5n to the 4th over n to the 7th. Downstairs, n to the 7th over n to the 7th minus 2 over n to the 7th. And we've done this enough now, we can see what's pretty much going to happen here. We have the limit as n approaches infinity of n to the 7th divided by n to the 7th is 1, minus, this is going to become 0. And then we're going to have 1 minus 0. And this is the limit. The limit equals 1. So if the limit is a finite number, if the limit as n approaches infinity is equal to some limit L and not infinity, then because B sub n converges, A sub n also converges. The rule is that if the limit approaches a finite value L, then both the series and the integral, the limit, converge or diverge. So since both A sub n and B sub n will either both converge or diverge. And so since, where did we say that? Way back up here, B sub n is a converging P series. So since the limit is a finite number and B sub n converges, A sub n also converges. So this is exactly how you should be doing every single problem for the homework. You should be doing the direct comparison test and the limit comparison test. Now, the direct comparison test doesn't always work. If it does not work, like it did not work in this problem, you need to show me why. Then go on and do the limit comparison test. Now, the limit comparison test can almost always be used. Sometimes it's more difficult to use the limit comparison test, even though it will always work. But for these problems, I want you to show both the direct comparison test, showing all the work just exactly the way I showed here, and the limit comparison test. All right, hopefully this was a nice little helpful video to get you started on your homework.